All right, we're going to cover 7.4 and 4.8 today. So that'll leave us, because 7.5 we will do on Wednesday. Okay. What 7.4 is covering is quadratic equations and what those functions look like on a graph and what it means to find the solutions or the answers to quadratic equations and how that translates to what that's talking about on the graph. So first of all, let's just talk about what a graph of a quadratic equation is. Quadratic equations are equations where their highest exponent is a 2, or in other words, those x squared equations. Okay, anytime you graph an x squared equation on your graphing calculator or wherever you're going to graph it, you're going to come up with this shape. An x squared graph is always going to be that U or parabola shape. Okay, so for instance, let's say you have a parabola and you graph something and you look at your graph and it gives you something that looks like this. Okay, so what this is showing is an x squared graph and it's got two x-intercepts. X-intercepts are where this U shape crosses through your x-axis. Those are called your x-intercepts. Another term for this would be the solutions of the quadratic function, or it's also called the zeros of the quadratic function. Okay, these 2 points, here's my x-axis, where it passes through the x-axis. Let's think about what that is. So this point, right, passing through the x-axis is a point. All points have an x coordinate and a y coordinate. Let's see, this one's x would be +2. Its y coordinate would be 0, right? Because you've gone to the right 2, up and down 0. This one gone to the left 3, so it's down to -3 on the x-axis. Its y coordinate is still 0. That's what makes you be an x-intercept. Is simply because the y coordinate of your point is a 0, right? Because the y coordinate being a 0 tells your point not to go up or down at all, to stay right on the x-axis. So that's why sometimes they're called x-intercepts. Sometimes they're called zeros because they're the points where the y is 0. And then sometimes they're called the solutions. Okay, what we're going to do today in section 7.4 is, instead of finding the x-intercepts or these solutions or zeros by looking at the graph, we're going to find them algebraically, like on number 1 in 7.4. You've got f of w, it says find the zeros of this function. F of w equals w squared plus 12w plus 27. So the steps that we're going to take are, first of all, this is the same thing as your y, right? So a lot of times, most of the time we see it as f of x. This time it's just f of w, just because w's are the variables they're using in this problem. But this is the same thing as saying y equals w squared plus 12w plus 27. So the first thing you want to do, because what did we say about all x-intercepts? What they have in common is that their y coordinate is a 0. So I'm going to replace the y with a 0. Now, what we're going to try to do is solve this. We're going to use 2 different methods outside of graphing to solve quadratic equations. The first option that we're going to try is to solve it by factoring. Okay, if you can use factoring, that's going to to be your easiest route to get to the solutions. Okay, when you're factoring, what you're doing is you are finding what was multiplied together, or in other words, what are the factors of w squared plus 12w plus 27? Or what are the two binomials that they multiplied together to get this trinomial? In other words, I'm going to unfoil here. Okay, so when we are factoring three terms, and your first term has that invisible 1 in front of it, that's actually what you really like to see. Because if you think of this as unfoiling, when we foil, what's the first thing we do? We multiply whatever's here times whatever is here. When we multiply those two things together, they have to give me w squared. And there's actually only one way to do that, right? What times what gives you w squared? Well, the way you're going to get that is w times w. After this part, then you think, okay, what is the last part of FOIL? The last part is you multiply these two numbers together. And in this case, these two numbers multiplied together have to equal 27. So let's just give our options of that. That's either 27 times 1 or 9 times 3. Those multiply to give me 27. But the other thing that these two numbers also have to do is add to equal the middle number, which is 12. So when you're looking at these pairs that are coming in from like my word box, my place I'm choosing from, which one adds to 12, the 9, and the 3 does? So that right there, you have a positive 9 and a positive 3, right? You need them both to be positive because not positive 9 times positive 3 is positive 27. Positive 9 plus positive 3 is positive 12. When your signs are the same like this, it doesn't matter which order you put the 9 and the 3. It can go in either spot. Okay. Now, after you do the factoring, you're going to set both of your factors, whatever you ended up with here, equal to 0. And then solve them for these W's. So on this first one, I'll have to subtract the 9 from both sides. So here, W equals negative 9. And here, subtract the 3 from both spots. So here, W equals negative 3. So negative 9 and negative 3 are your zeros or your solutions. Or if you put in your graphing calculator, x squared plus 12x plus 27 and graph that U shape, you would see it's going to cross the x-axis at negative 9 and negative 3. So your best case scenario is a factoring solution. But not everything is factorable, because what if there are numbers here that you can multiply, but none of the pairs add to the middle number? That just simply means that factoring is not an option. Now, I'm going to go out of order from the handout that I actually didn't send out till 7:30 this morning. So if you're trying to follow along, it is in your student email now, but it wasn't until 7:30 this morning. So I'm going to skip around a little bit. I'm going to skip number 2 and come back to it. I'm going to go to number 3 now. So number 3 is x squared plus 5x minus 3 equals 0. X squared plus 5x minus 3 equals 0. So don't write this down. If I did try to use the same method that I did last time, okay, here's the part I don't want you to write. I would start off to get x squared. That's no problem. I'll just use x and x. But then what's the next step? You're multiplying to equal this last number, which is negative 3. So either 3 times negative 1, or I can flip the signs. Negative 3 times positive 1. Those are fractions to multiply to get -3. But remember, what do those two numbers also have to do in order to use the factoring method here? They would have to add to +5. That's not adding to +5, and neither is this, which simply means factoring is not an option. Which is why we have the quadratic formula. Which is x equals, I'm going to call this the opposite of b, plus or minus the square root. Then underneath your square root, you're going to have your b, but square it, -4 times a times c. That's going to be in your numerator. Your denominator is going to be 2 times your a. So where are all these a's, b's, and c's coming from? When you are looking at your equation, your a is the number that is in front of x squared, which is an understood 1 in this case. Your b is the number in front of x, and your c is your constant, which is the number that doesn't have a letter hooked onto it. I like to write them out to the side like this so I can come back to them when I need them. So my a in this case is 1. My b is +5, and my c is -3. So I'm going to use this formula wherever I see a, b, and c. I'm going to put in what numbers go with that. So let's see, I need x equals. Now, here's why I call this the opposite of b. I don't like to say -b and then come over here and say, okay, b is 5. So what do I put? Is it -5, +5? But if you call this the opposite of b, and then you come over here and you see b is 5, well, the opposite of 5 is -5. So you're just going to put the opposite of that sign there. Then you're going to have the plus and the minus symbol. That's actually what's giving you your two separate solutions. Then you're going to have the square root that's got all kinds of stuff under it. The first thing it has under it is your b number, but you're going to square it. Remember, squaring doesn't mean to multiply it times 2. It means to multiply it times itself. So if I multiply this number times itself, I get 25. Now, after the b squared, here's a number that's just always in your formula, -4 or -4. Then a and c. A and c in this case are 1 and -3. Signs are important. 1 and -3. Then in the bottom, the denominator of the quadratic formula is 2 times whatever your a is, which in this case is 1. The rest of the problem deals with simplifying this fraction. The first thing I'm going to do is figure out what all this is under here. So I'm just going to bring this down. The -5 plus minus, I'm actually going to bring down the square root. Now, let's see what's under that square root. Just type in exactly what you see, which is 25, then the -4. Then, just like what I see there, I have open parentheses, 1, close, open parentheses, -3, close. So just like I have underneath the square root, 25 -4. Open 1, close, open -3, close. Hit enter. So underneath your square root, you just actually have 37. That's what you put here. Your denominator, 2 times 1 is 2. So that is, now when you're looking at number 3, It's going to ask you to enter your answer two ways. It's going to ask for exact solutions, and then it's going to ask for approximate solutions to 3 decimal places. This is your exact solutions. Okay, there are actually 2 solutions being shown here because of this plus and minus. So when you're typing this into MATLAB, it actually has down there in your toolbox where it has all the things that you do to type in funny symbols and things like that. It has a little plus minus button. So what you would do when you're typing this in is, first of all, hit your fraction button down in your toolbox, right? Because you're going to have a long numerator and then a simple denominator. When you're typing in your numerator, you can type in -5, then come back down in your toolbox and hit the plus minus button, and then type in the square root of 37 over 2. Okay? If you don't, then you actually, because what MATLAB says, actually, you have to type in your 2 solutions separated by a comma. So if you don't hit the plus minus button, what are you going to have to do? You're going to have to type in -5 plus the square root of 37 over 2, comma, -5 minus the square root of 37 over 2. You don't want to have to do that, right? So that plus minus takes care of that. Now, the second thing it's going to ask you for is, what are the approximate solutions to 3 decimal places? So you are going to have to type this in your calculator. So one of your approximate solutions is going to come from the plus 37 or plus square root of 37. So when you are typing this in your calculator, you're going to want to put parentheses around that. Okay, that's going to group your numerator together and make it the whole numerator. So you would do open parentheses, -5. Okay, my first one I'll do plus. Now remember, here's square root right here on the x squared button, but to get to it, I need to hit second, right? Since it's blue. So second square root, type in the 37. Now look how my cursor is still under the square root. I'm done being under the square root now. So hit this right arrow and then watch what it does. It ends, it says, okay, you're done with typing in the square root. Then you're going to close that. And then you just have to put the denominator. So hit divided by whatever my denominator is. In this case, it's 2. And then hit enter. And it's going to say, okay, I want you to type it into 3 decimal places. So let's see, behind the decimal, if I go 1, 2, 3, I have to check to see whether I need to round that 1 up to a 2 by looking behind it. If the number behind that 1 is 5 or higher, then I would need to round it up to 0.542 because it doesn't want me to type in the whole thing. It just wants me to go to the 3rd decimal place. So since that's a 3, I don't need to round that up. So my first approximate solution is 0.541. Okay, and it's approximate because it doesn't exactly equal 0.541, right? We even saw it, the decimal even goes off the calculator here. So that's why it's approximate. My other approximate solution is from putting in minus the square root of 37 over 2. So exactly what I have here. It's just that instead of plus, put minus. So open, -5 minus second square root 37. Now remember, get out of there by going to the right arrow, then close the top and hit divided by 2. So again, if I go 1, 2, 3 places behind the decimal, check to see if I need to round up. That's a 3, so I don't. So -5.541. Is your other approximate solution. So that's how you use the quadratic formula. Okay, I'm actually going to skip number 4. So I've done 1, I've done 3, I've skipped 2, I'm skipping 4, I'm going to do 5 and then 6. So here's number 5. 3x squared minus 7x minus 5. Equals 0. All right. So I'm going to choose my A, B, and C. So in front of x squared is my A, so it's 3. In front of my x, that's the B number, so it's negative 7. And then this last number, the constant, is negative 5. Plugging in, what's the first thing you need? The opposite of your B. So this time my B is negative 7. So the opposite of it is going to be positive 7. Then your plus minus. Then the first thing under your square root is your B, but you're going to square it. So this number right here, it's not going to be a negative number, right? Because even if your B that you're squaring is a negative number, what happens to it when you square it or multiply it times itself? Negative 7 times negative 7 is positive 49. So you still are going to have a positive number there. What comes after B squared? Minus 4. And then times A and C. A and C this time are 3 and negative 5. All over 2 times A, which in this case is 2 times 3. So let's see what's underneath that square root. I'm just going to bring down the 7, plus or minus. Figure out what that square root is. Again, you're just punching in your calculator. What's underneath the square root? 49 minus 4. The negative 4, Molly's asking this question. The negative 4 is just actually part of the formula. It's going to be there every single time in every problem that you use the quadratic formula, because it is this part right here. It comes in every part of the problem. Okay, so when I'm typing it in, I'm going to have 49 minus 4. Then open. Let's see, I have 3 and negative 5. So open, then the 3, close. Then open again, negative 5, close. And hit enter. So underneath that square root, when you multiply, when you figure out this, it does the order of operations and everything for you. It comes up with 109. And then the denominator was 2 times 3, which gives me 6. Those are your exact solutions. So that's what you put in for exact. Then it's going to ask you for the approximate solution. So remember, that's just typing in your exact solutions in your calculator and hitting enter, and then rounding that decimal to 3 places. So typing in exactly what my answers were, 7 plus the square root of 109. And remember, when I'm typing in that numerator, you have to put parentheses around it. So open 7 plus, then your square root. So the second button and then the x squared button will give you your square root. What is it? 109. So 109. Then remember, you also now need to say, okay, now I'm done typing in my square root. I want to make my cursor be outside of it. So just hit the right arrow. And then you're done with the numerator. So close it off with a closing parenthesis. And then hit divided by, right? Because that makes the fraction bar of your fraction. And then this time my denominator is 6. So I'll just put it over 6 and hit enter. So here's my first approximate solution. This time, when I go 3 places after the decimal, I need to see whether or not I need to round this 6 up to a 7. If the number after it is 5 or greater, then I'm going to round that 6 up to a 7. And it is. So this 7 just simply makes this 2.907. So that's your first approximate solution. Then your second one, I'm going to type in the exact same thing. It's just that this one's going to come from 7 minus the square root of 109 over 6. So again, open parentheses, 7, this time minus the square root of 109. So second x squared, that gives me my 109. All right, I'm done typing in my square root. So I'm going to hit the right arrow and close off my numerator. Again, over 6. So divided by 6. Hit enter. Let's see, 3 spaces. 1, 2, 3. So let's see if we need to round this 3 up to a 4. And we don't, right? Because that's below a 5. So the other approximate solution is negative 0.573. Okay, another one that's very similar to this one. Number 6. F of x equals 3x squared minus 5x minus 11. So again, my A, B, and C are 3. Be careful with your sign. Negative 5 and negative 11. Plugging in the opposite of B. So the opposite of this B is positive 5. Then your plus minus. Under the square root, you're going to need your B number, but you're going to square it. And remember, when you square a negative number, if you're doing that in your calculator, you need to be telling it negative 5, which means you would need to have to put parentheses around it if you're going to square a number in your calculator. So negative 5 squared gives me positive 25. Then negative 4 times A and C. A and C are 3. And negative 11. And then your denominator from the formula is always 2 times whatever your A number is. So 2 times 3 in this position. Now let's figure out what all this is. I'm going to put it in my calculator just like that. So let's see, I'm going to have 5 plus or minus. Let's see what that is. So I've got 25 minus 4, open parentheses, 3, close, open parentheses, negative 11, close. So just exactly like you see underneath that radical. Enter. So underneath the radical, I really just have 157. Then my denominator, 2 times 3, gives me 6. Okay. Hang on, I got to plug in my computer. Just tell me it was running low. On number 6, you'll notice, though, that it just says the zeros are blank. It's not asking for the approximate. It's not asking for the decimal answer on number 6, just that square root answer. Okay. Okay, now the ones that we skipped were 2 and 4. Let's do number 4 first. But before we get into actually working the problem, I want to re-go over something that it's just assuming that you already know. But sometimes people just aren't taught this, or they just don't remember talking about it. What happens if during solving the quadratic equation, what's underneath your square root ends up being negative? Okay, what does that mean? If you have a negative under a square root, let's see, you just end up with that under your square root. Math Lab's not going to let you put this in because technically a negative under a square root is not mathematically, I don't know what the word is, but you can simplify it. You can simplify it because the square root of -1 is actually an imaginary number. It's going to be what's called an I. So all you have to do, think about pulling the -1 out of this. All you're doing is taking out the I, which makes what's underneath your square root positive. So if you're working a quadratic equation and you end up with a negative number underneath your radical, you need to pull the I out of it. That's pulling the negative out of it. Because that's what's going to happen on number 4. F of x equals 5x squared minus x plus 9. Looks just like the rest of them. So I'm still going to choose my A, B, and C. Okay? A is in front of your x squared, which means it's 5. B is in front of x. All I see is a minus. That means it's a -1. So your B is -1. And your C is +9. Nothing out of the ordinary yet. So let's plug our A, B, and C into our formula. So the opposite of B, here's my B, which means the opposite of it's going to be +1. Then my long square root. Then your B, but you square it, which means multiply it times itself. If I square -1 or times it by itself, it gives me +1, right? Because -1 times -1 is +1. Then the -4 from the formula. Your A and C again, which are 5 and 9. That's all over 2 times A. This time my A is 5. So my denominator will be 2 times 5. Just like always, my next step to figure out what that is. I'll just do it in my calculator. I have 1 minus 4, open parentheses 5, close, open parentheses 9, close. So just exactly what you see underneath your square root. When you hit enter, you get -179. I've got 1 plus or minus the square root. I just figured out underneath my square root is -179 over my denominator, which is 2 times 5, which is 10. So this is why this one has that 1 extra step, because of this negative. Okay? This means I just need to pull out the I, and you just put it right here in front of the square root. You're going to have 1 plus or minus I square root of 179 over 10, okay? Your toolbox will have that I, or you can just use the I on your keyboard. Either one's fine when you're typing in that answer. Okay, this one you're not going to have approximate solutions because it's an I. There is not a number line. You're not going to be able to go to the number line and find this number. It's not on a number line. It's not a real number answer because it's got that I in it. Okay. Last one for this section. Number 2. F of x equals x squared minus 2x minus 4. Starts off looking very much like the other ones. I'm going to go ahead and pick my A, B, and C. A, front of x squared. I don't see a number. That means there's a 1. Your B number is in front of your x, so it's -2. Then your C number is your constant, which is -4. Now, let's plug this in. Let's see. Formula, the opposite of B is +2. And plus or minus the square root. Underneath my square root, I have my B, but square it. So -2 times itself is +4. Then I'm going to have -4 times A and C. A and C are 1 and -4. All that over 2 times A, which in this case is 2 times 1. Right? Nothing new yet. All right, let's do this in our calculator right here. I'm going to have 2 plus or minus. Let's see what's really under that square root by putting that in my calculator. So 4 minus, open parentheses. No. 4 minus 4, then open parentheses 1, close, open parentheses -4, close. So just like what's underneath your radical, this time when you hit enter, you get 20 over my denominator, which is 2. Here's what's different about this one. This square root of 20 is not completely simplified. The other times when I got to this point, the numbers I had underneath my radical were 37, 179, 109, 157. All those numbers were simplified as they can be. And here's what that means. If you have a factor that is a perfect square underneath your radical, you can simplify this radical. Here's what I mean. Let's look at the factors of 20, which means what numbers multiply to give you 20. 20 times 1, 10 times 2, and 5 times 4. What is a perfect square number? A perfect square number is a number that when you take the square root of it, you get a whole number and not a decimal. Okay? In other words, if you take the square, and we're not counting 1, this top one, since it's already a 20, if I break it up to 20 and 1, I haven't done anything. I still have 20. But if I take the square root of 10, it's going to give me a decimal. If you take the square root of 2, it's going to give you a decimal. Square root of 5. Decimal. But what do you get if you type in square root of 4? Not a decimal, which what that means is there is a factor, because 4 is a factor of 20. It is one of the numbers that multiplies and can give you 20, and it's a perfect square. Perfect square numbers are like 4 because the square root of 4 is 2. The next perfect square number would be 9, right? Because the square root of 9, or in other words, what times itself is 9 is 3. The list goes on. 25 is a perfect square, right? Because 5 is its square root. So that means because of this number right here, that this right here is not all the way simplified because there is some perfect square under your radical. So here's how you fix it. You're going to break this 20 apart. So just bring down the 2, plus minus. You're going to break that square root of 20 apart into 2 square roots. They have to multiply to equal 20. And if not, then you've changed the problem. But they have to multiply to equal 20. And the one that you put in this first radical has to be a perfect square. Which one of those numbers did we say was a perfect square? 4. So it comes here. 4 times what is 20? So we need to put a 5 there, right? Because 4 times 5 and 20 are the same thing. My denominator is still a 2. So since we broke this up and took the squareness out of that radical, what is the square root of 4? It is plain old 2. So now I've just got 2 plus or minus, this is a plain 2, because the square root of 4 is just 2. Square root's a 5. My denominator is still a 2. One last step. This is why we save this one for last. If these 3 numbers all divide by the same thing, you can divide that number out. In other words, this fraction can reduce. Okay, the number that goes into all those 2's is 2. So if I divide them out by 2, what are they all going to turn into if I divide them all by 2? They're all going to turn into 1s. So let's see what's left in this fraction. Let's see, in front of my plus minus, I've got a 1. Then I have my plus minus. Behind my plus minus, I have 1 square root of 5. It's just that I don't need to, if you have 1 of something like 1x, it's not necessary to write that 1, right? 1x is just the same thing as x. Well, 1 square root of 5 is just the same thing as saying the square root of 5. Also, if you have a fraction, but the denominator is just a 1, there's no need to write that 1 either, right? Over 1 just means you don't need it. So this right here is your final answer. And luckily, that one does just ask us for the exact answers. We don't need to type in the decimal answers. Okay, so that was 7.4. We are also going to do 4.8 today. And the first 2 part of it is not too bad. When I'm looking, hang on, at 4.8, the first 2 problems are going to give me the picture of a graph. So like we did at the beginning of this lecture, what you're finding when you find the solutions of this quadratic equation that makes a U shape, what are you finding? You are finding where the U-shaped parabola crosses through the x-axis. That's what you're finding when you are finding these 2 solutions. Okay, so tying it together in 4.8, it's actually going to, instead of giving us the, actually it gives us the equation, but it also gives us the picture of the graph, which makes it much more simple. We don't have to solve anything, we just have to look at the picture. So it's x squared minus 2x minus 15 equals 0. but then it actually shows you the physical graph. Oh, shoot. So it shows you this graph. The first thing it says is the x-intercepts are blank. And there's two of them, right? This shape crosses through the x-axis in both of those spots. When it's asking for x-intercepts, it's asking for what is the ordered pair of each of those points. So this first one, now remember, there's two of them. So it's going to want you to enter it like this. Remember what makes you be an x-intercept, what makes your point not go up or down. It just stays right on the x-axis because its y-coordinate is 0. So both of the y-coordinates are going to be zeros. Then you just look and see where it crosses the x. Here it crosses it at -3, and here it crosses it at +5. So your two x-intercepts are at -3, 0. And also at 5, 0. So those are your x-intercepts. Then it's going to say the solutions are x equals. All it wants to know here, it's not asking for the intercept, it's asking for the solutions. Or in other words, if you solve that using the quadratic formula or however you solve it, then you would come up with -3 and 5. Those are your solutions. These are not in parentheses because it's not talking about the actual x-intercepts. Okay, so x-intercepts are entered as points. Solutions are not entered as points. That you just look at where they cross up there. Okay, number 2 is the same kind of problem. You've got 5 plus 4x minus x squared equals 0. Five plus 4x minus x squared. Okay, so you can either do that by quadratic formula or factoring, however you saw it fit, or you can just look at the picture. This one's actually upside down, and that's upside down because that x squared is negative. So let's see, my x-intercepts. Remember, those are the ordered pairs, and both y-coordinates are going to be zeros. Let's see, it crosses here at -1, 0, and here at +5, 0. So if those are your x-intercepts, that means the solutions are -1 and +5. Again, x-intercepts need to be entered as ordered pairs. Your solutions are just the two answers there. Okay? Hang on, I'm going to pause for just 1 second. I'm going to try. Okay, on this next one, this is going to give us kind of like a real life problem that goes with solving these. Okay, it's going to say a wire is stretched from the ground to the top of an antenna tower. So this is what this would look like. Okay, so this right here is a wire. And here's your antenna tower, right? Just coming straight out of the ground. There's a wire attached from the ground to the top of the antenna. Okay, let's see what it tells us. The wire is 35 feet long. So it tells us this is 35 feet. The height of the tower is 7 feet greater than the distance from the base of the tower to the end of the wire. So in other words, the height of the tower, so here's my tower, is 7 feet longer than the distance from the base of the tower to the wire. So this, we're going to call this side X. We don't know how long it is. All we know is that the height of the tower is 7 feet longer than this. So this side will be X plus 7. So what we're going to do, again, some prior, why didn't somebody say something? So what we're going to do here is set this up. When you have a triangle that's a right triangle, you can use what's called the Pythagorean Theorem to solve for X. What the Pythagorean Theorem says about all right triangles is the length of one side squared, so we'll just call that A squared, plus the length of the other side squared, plus B squared is equal to the diagonal side squared. So that one we're just going to call C squared. You may have heard this before. A squared plus B squared equals C squared. Okay, that's what this goes along with, is right triangle. So let's fill in what we know. What do we know this side is? What was the diagonal side? 35. And I got a square. So 35 squared. The two sides doesn't even really matter in what order that they go. We just need to square them and add them together. So let's see. We've got X plus 7 squared plus the other side is X squared. So this side squared plus this side squared equals the diagonal side squared. Now we got a bunch of work to do, because I'm going to do this part over here. What does X plus 7 squared mean? It means X plus 7 times X plus 7. If I FOIL this, X times X squared. X times positive 7, positive 7X. My inner, positive 7 times X is another positive 7X. And then my last 7 times 7 is 49. If you combine your like terms, that will give you 14X. So you've got X squared plus 14X plus 49. So that's what X plus 7 squared gave me. X squared plus 14X plus 49. I'm just going to drop down that plus X squared. Equals 35 squared, if you put that in your calculator. $35 squared gives me 1,225. So remember, so this is going to be a quad equation because it's X squared. Now on the left, I need to combine my like terms, right? Here's my equal sign. If you have like terms that can be put together, this is now the time to do it. There's 1x squared here and 1x squared here, which means you actually have 2x squareds on the left side. Then the plus 14x plus 49, drop down to 1225. Now, what we didn't talk about before you pick out your A, B, and C is you have to have it set equal to 0. We did it on the first couple of problems. You always want the side opposite of all your terms to be a 0. So I've actually got to subtract this 1225 from both sides. Cancels here. There's my 0. On the left, I've got 2x squared plus 14x. When I do that, 49 minus 1225, what do I get? Negative 1,176. So there is a couple of different ways I can go about this. Okay, after we do this problem, I'm going to show you how to do it in the calculator. So it's not going to be real important that you know how to do this part mathematically, but I can actually factor this. I need to, first of all, I can divide this whole side since they all divide by 2. I can do the same thing. I have to do the same thing over here. That's not going to mess up my 0 though, right? It's still going to be 0, which is what it has to be. It's just going to make these numbers a lot smaller to deal with. So if I divide everything over here by 2, what am I going to get? Let's see. 2 divided by 2 is just going to give me 1x squared, which is what I like. Plus 14 over 2 is 7x minus, I don't know what that is, 1176 divided by 2 gives me 588. So minus 588. Now, I could either factor that, which that does, just like number 1 did in 7.4. This also factors. The numbers aren't as pretty, but it can factor. X and x for x squared. So here's the ugly part. I'm trying to divide negative 588 to find out its factors that maybe add to 7. I'm going to show you how you can do that in your calculator. If you go to your y equals, this can work any kind of high number factoring problem. Whatever number you're trying to find the factors of, which is negative 588, divide it by x. So divide by x. I don't care what this looks like on a graph. What I want to see, this right here is going to tell me all the numbers that go evenly into negative 588, which is what I want. I want to see the table of those numbers. So hit second, table. I'm not done yet. So there's all the numbers. You just ignore numbers that have decimal. I don't even see any numbers with decimals. It's just giving me all the good numbers. So these are factors of negative 588. Negative 1 times 588. Negative 2 times 294. Negative 3 times 196. Apparently 588 has a lot of factors. I just want to know the 2 factors that also add to the middle number, right? They have to multiply to equal negative 588. I got all that done. But I only want to see the pair that adds to positive 7. So I could go through and add these together all the way until I find the pair that adds to 7. It's going to take me a minute. Or I can go back to y equals, go down 1. So now type in the same exact thing you see here. So negative 588 divided by x, but now you're going to throw in a plus and then hit x again. And then go back to your table. So what this third column over here is doing is it's adding the first 2 columns together. So what would you be looking for over here in the third column? You'd be looking for positive 7. There it is. So I just scrolled up or down until I found the number that matches this in that last column, because remember what the first 2 columns do. They multiply to negative 588. This third column adds these 2 numbers together. So those 2 numbers add to 7, which is what I want when I'm factoring these, right? So what are those two numbers? Negative 21 and positive 28. So now, what do? Remember number one, back in that first section, 7.4. You get your factors, you set them equal to 0, and you solve them. So I need to add 21 to both sides here. So here, x equals 21. Here, when I subtract 28 from both sides, I get x equals negative 28. Let's see. So here, I have two different solutions for x. Only one of them. Think about what makes sense and what doesn't. Let's see what x is. The x is going to be the distance from the wire to the tower. The distance from the wire to the tower. Look at your options. Positive 21 or negative 28. One of those doesn't make any sense. If you are a physical distance from here to here, which one of these does not make sense? The negative answer doesn't make sense. You're not going to be a negative distance away. So your x is 21, and your x plus 7, just add 7 to that. So your x plus 7 is 28. So the distance from the tower to the base of the wire is 21, and the height of the tower is 28. Okay, before we do that very last one, which is actually not near as complicated as that one, even though it seems like it's going to be, I want to show you what I have on my calculator. And then I'm going to give y'all the option to put this on your calculator, because it's going to help you. All this quadratic formula stuff we've been doing today, there's a program that you can put on your calculator. I have it on mine under program. I have a bunch of programs. I'm going to go down to the one called quad. You do not have this on your calculator unless you got it from somewhere. It doesn't come already on your calculator. So if I go down to quad and hit enter again, look what's going to ask me. It's going to say, okay, in your problem, what is your A? Remember the A, B, and C that we always choose? What would have been A, B, and C once we got to here? A would have been 1. B would have been 7. C would have been negative 588. You tell this quad program that it's going to do, watch what it'll do. A is 1. B is 7. So that's what after you enter A, it tells you what's B, 7. Then it's going to say what's C. Ours is negative 588. Look what the quad program does for you. There's your two solutions, 21 and negative 28. So you can either meet me here and I can sync our calculators. If you are going to meet me, your calculator needs to have this hole, okay? I have this hole, but I don't have the connecting thing yet. I'm ordering it on Amazon to have that mini USB. But I have the cord that will connect my calculator to yours with this. So you can either work these all out by hand, which you have now all the tools to be able to do that. But if you have that quad program, as long as you know your A, B, and C, you're just typing it in every time. On that whole 7.4 that we just worked before this, every single one of those could be worked in that quad program in about 5 minutes, the whole assignment. Okay, now this last problem says the foot of an extension ladder is 7 feet from a wall. So it's going to make the same shape, because if you have an extension ladder and a wall, here's my ladder, here's my wall, here's the distance from the wall to the ladder. Okay, and it says it's 7 feet. The foot of the extension ladder is 7 feet from a wall. So the foot of the ladder, which is right here, is 7 feet from the wall. It says the height that the ladder reaches on the wall and the length of the ladder are consecutive integers. That means one comes right after the other. So what does it say? The height of the ladder reaches on the wall and the length of the ladder. So the length of the ladder is the number right after this one. So if we call this one X, that's just going to be add 1 to it, right? That's going to be the consecutive or the next number. So let's see, set it up again. And you'll see why this ends up actually being better, right? This side squared plus this side squared. So X squared plus 7 squared equals, that's this diagonal side squared. So let's see, I've got X squared plus 7 squared, which is 49, equals. Now I still need to come over here to the side and FOIL that to see what I get when I multiply X plus 1 times itself. So if I FOIL this, my first, X times X gives me X squared. My outside, X times positive 1 is 1X. My inside is another positive 1X. My last, positive 1 times positive 1, 1. Again, put your like terms together. You actually have 2 X's here. So X squared plus 2X plus 1 is what this side will end up being. So, right, I did the work over there. X squared plus 2X plus 1. So now, here is where this becomes simpler. Because remember, I can do anything to one side of an equation as long as I do it to the other. So let's see what happens. This time my X squareds are on opposite sides. The last problem, they were both over here, so I had to put them together. But if they're on opposite sides and I subtract one, I have to subtract the other, which cancels them off of both sides. You don't have X squared anymore. Look what you have left. You just have 49 equals 2X plus 1. Now I'm just plain old solving for X. I don't have to worry about X squared kind of steps. I just want to get that X by itself. So I'll subtract the 1 from both sides. So now I have 2X equals 48. My last step is to divide by 2. So what does X equal? 48 divided by 2, which is 24. Now be careful here. X is 24. Which means this side is 24 plus 1, or in other words, the next or consecutive integer. So it's 25. The only question that this problem is asking you is the length of the ladder is blank. Well, which one is the length of the ladder? Just that one right there, 25. Excuse me. Okay. All right, that was a lot. But we got 7.4 and 4.8 done. So on Wednesday, we'll just have 7.5. Hang on, let me take roll. Excuse me. All right, got. All right, okay. Andrew Holcomb, Emma Mitchell. Let me pause this.